Alright, so continue from the previous lessons about the compound angle formula in trigonometries. So here are the 6 formulas we have done. Yep. And then I would like to show you some applications of using those 6 formulas. In year 12, we are going to use this one a lot of times. You need to memorize it. I'm just going to say one more time. Memorizing of those formulas is so important. Otherwise, you'll find it's really hard for you to do questions later on. Okay. All right. So we're going to start with the first example. Example 1. I just want to show you a few variety of questions. Right. So the first example is like show that sine 15 degrees is equal to square root of 3 minus 1 over 2 square root of 2. Okay, now as you know, that 15 degrees is not a special angle. And how do we show that? However, on the right hand side, you've got the exact solution. Your calculator is not going to give you square root of 3 minus 1 over 2 square root of 2. But using the compound angle formula, we can do this. Okay, now 15 comes from 45 degree minus 30 degrees. And both 45 degrees and 30 degrees are special angles. So we can do that. So if we're starting from sine, instead of writing 15 degrees, we write 45 degrees minus 30 degrees. Then we're going to get, using the compound angle formula, sine 45 cosine 30 minus cosine 45 and then sine 30. So that's one of the application. We can use the compound angle formula to break down the angles. Alright, so we have those special angles, and then we can actually to the questions. Now, using the special angle tables, you should be able to work out what is sine 45, cosine 30, and the rest of them. Sine 45 root 2 over 2. In this case, I guess they're using 1 over root 2. Okay, so 1 over root 2. Times by cosine 30, root 3 over 2. Minus 1 over root 2 again. Just write better. Okay, 1 over root 2. And then times by half. So that gives you root 3 over 2 square root of 2 minus 1 over 2 square root of 2. And that gives you square root of 3 minus 1 over 2 square root of 2. And that's it. Done. Alright. So that's the first example. Really simple, easy. Alright, now example 2. Similar idea, but this time they don't provide you the answer. They ask you to find tangent 75 degrees. And they ask you to find the exact value. Alright, so you can leave the answer in the exact value. Alright, easy. Tangent 75. Hopefully you realize that 75 can be broken down into 45, but this time plus 30 degrees. Alright, and then you're going to use the compound angle formula for tangent. So it'll be tangent 45 plus tangent 30 over 1 minus tangent 45 tangent 30 degrees. Alright. Now from here, we should be able to use the special angle tables to work out the answer. Tan 45 is 1. Tan 30 is root 3 over 3. And then 1 minus 1 times root 3 over 3. Okay. Now from here, just make this a bit easier. We can times both the top and the bottom by 3. So that gives you 3 minus root 3 over 3. 3 plus root 3 over 3 minus root 3. You can rationalize the denominator if you want to, but I'm just going to leave the answer like that. Okay, that's the, not the rationalized form, but that's an exact solution. And that's using compound angles. All right, so that's the, sort of one, type of, question, okay, using the compound angle formula. I'd like to show you another type of question, okay, to find the exact value. So example 3. So the question says using the compound angle formula to find the exact value. Okay, so find the exact values of, and the question is this one. Okay, cosine bracket tangent inverse 1 over 2 plus sine inverse 1 over 4. Wow. Okay, here's the question. All right, involving inverse trigonometry, and that's a compound angles, right? So what do we do here? Same thing, but the first step here is you're going to change these two to two angles. Let's just call that alpha, that's beta. So obviously the first step you do is you said let alpha equals to tangent inverse 1 over 2, and let beta equals to sine inverse 1 over 4. So therefore tangent alpha is equal to half, and sine beta equals to 1 over 4. I'm just setting up the questions right now, all right? I am not solving the questions yet. I'm just setting up the question. All right. Now we need to determine which quadrant, okay? Very important, but otherwise we probably end up with multiple answers. Sine alpha is positive. All right, so wait, whoops, not sine alpha, tangent alpha. That is tangent alpha. Tangent alpha is equal to positive number here. So positive tangent is positive in the first and third quadrant. All right, first and third quadrants. So I'm just shade it. Okay, now, do you still remember what is the range for tangent? The range for tangent is between negative pi on 2 to positive pi on 2. So it's actually here and here. So therefore, that is the common region, which means that's the first quadrant angle. All right, so alpha is in the first quadrant. Now let's look at the beta. Sine is positive in the first and second quadrant. All right, so I'm just going to highlight here first and second quadrant. And then the range for sine inverse, the range for sine inverse, again, it is between pi on 2 and negative pi on 2, which means the common region is still in the first quadrant. All right, now, just to tell you a little trick here. Although I'm checking, okay, to see which quadrant, but I know automatically, I know it is in the first quadrant, okay? The question is designed that they only give you the first quadrant angle for a question like those. But I'm not saying that you don't check every single time. I'm saying that, it's better to check, okay, because they can be tricky and they give you a question that's different, and they give you a negative number inside, and then it changes everything. But highly unlikely they're going to give you a question like that, because otherwise it's just going to be too crazy, because the purpose of this question is not testing you whether you understand the inverse trig or not. It's actually testing you about the compound angle formula. All right? Okay. Now, I've got alpha to beta, so we can start to do the question. So that becomes cosine alpha. Oh, whoops. Before we do that, okay, I forgot about something. I still haven't finished preparing my question, okay? What I'm going to do is draw a right angle triangle. All right, and I call this is alpha, so I've got 1 and 2 because tangent alpha is, opposite over adjacent. All right, and then that becomes a square root of 5. Do the same thing for that triangle here. Trust me, draw the triangle first. That's 1 and that's 4. And then this side here will be 4 square, which is 16, minus 1, 15, root 15. All right, okay, now let's start to do the question. So I'm just going to do the question on the right-hand side to save some space. Also, I have unlimited number of pages using the software. Okay, anyway, so I've got the cosine alpha plus beta. Now we're going to use the compound angle formula. This is where we're going to use compound angle formula. Cosine alpha, cosine beta, minus sine alpha, sine beta. Now, why do we need to have the the right angle triangle? Because now you're just going to use the triangle here, these two triangles here, to work out what is sine alpha, sine beta, cos beta. All right. Okay, so sine cos alpha. We're going to use the alpha triangle. So cos alpha is 2 over root 5 times by cos beta. Now we're going to come back to this triangle. So you have to pay attention to the triangle. That is root 15 over 4 minus sine alpha. Sine alpha is 1 over 2, we know that. And sine beta is 1 over 4, we also know that as well. All right, to simplify this, that gives us cross this 2 out, root 3, cross this 2 out, 2. That is a root 3 over 2 minus 1 over 8. Okay, finally. 4 root 3 minus 1 over 8. That is the answer. All right, okay. I hope you understand how to do this question. All right. So first step, I'm just going to say one more time. First step, you're going to replace the tan alpha, inverse tan inverse sine by alpha and beta. And then you're going to decide the quadrant, and then you're going to draw a triangle. So you can have all three sides before you can substitute the number C. All right. Okay, now example 4. For an example 4, I would like to pick, because I've already picked 2 questions, that is, using the compound angle formula to find the exact value. And then I pick a question involving inverse trigonometry. I think this time I'm just going to pick a question that's asks us to solve trig identity questions, alright? The trig identities. The one I always like, when I was a student, trig identity is always the question I find is really hard to do, okay? But, why not? Let's just pick one. Which one should I pick? How about just picking an easy one, okay? Proof. And you guys can do the harder questions later on. Alright, prove 2 sine x minus y over cosine x plus y minus cosine x minus y equals to cotangent x minus cotangent y. Okay, here's the question. You're going to use the trig compound angle formula to prove that. Okay, we're going to start from the left hand side. I'm just going to use different color. Left hand side. 2 sine alpha, or not alpha, x minus y over cos x plus y minus cos x minus y. Alright. Let's expand, okay? So that gives you, okay, what's the best way to expand that? So I've got 2, so let's put a bracket. Sine x cos y minus cos x sine y over cos sine, so cos x cos y minus sine x sine y. Here's minus, so you have to be, you have to just pay attention. Because that's a minus, I would like to put another bracket just to be 100% sure I don't make any silly mistakes with the algebra. Alright, okay, so alright, once you finish that, the good thing about using an iPad here is I can just remove the brackets and then change the sign to negative. Oh, that feels so good. I don't have to rewrite again. Okay, cool. Now, what I would like to do is to cross out the common terms. Those 2 are the like terms, so I can cross them out and rewrite again. Alright, so now what we need to do is combine these 2 terms together. Alright, they are the same term, like terms, but that becomes negative 2 sine x sine y. Alright, so 2 and 2 crosses out, so you've got negative. Now, I would like to show you a little magic, okay? That negative, you can move to the top, and you can just switch the position of these 2. Not really a magic, I hope, or I think you guys already know. Alright, if you don't know, try to find out why, okay? Alright, now what I need to do is break down this fraction into 2 fractions. So minus sine x cos y over sine x sine y. Oh, okay, from here you can further cancel the terms you don't need. And these are the 2 terms you cancelled. And I wish and I hope and you finally can see that cos over sine is cotangent x. And cos y over sine y is cotangent y, which is the right hand side of something we need to prove. Okay, done. That is the example 4. Alright, now this exercise, this exercise 17D is really, really hard. It will take a long time for you to do, okay? But trust me, if you just pay attention to the video I recorded, and then try to do the question after I finish an example, maybe just do the one example yourself, and then try to slowly learn those questions. You will get better. It took me a while to learn those when I was a student, so it's totally fine if you don't understand or don't know how to do the question when you do the question as a first trial. Okay, I hope everyone enjoyed the lesson. Thank you.